Welcome back, guys. Let's look how to solve questions as regards to Lusac's law of combining volume. Students have been asking me questions as regards to this, so I thought to do a video on explaining how to solve questions on Lusac's law of combining volume. Right. So question number 1 says 100 cm cube of nitrogen is sparked with 30 cm cube of oxygen. So first of all, we try to write the equation and then balance it up. Right. Step 1 is to write the equation. It said 100 cm cube of nitrogen, right, is sparked with 30 cm cube of oxygen. So this is nitrogen plus oxygen, right? This is the gaseous form of writing nitrogen and oxygen, right, at 100 degrees Celsius at 1 atmosphere. Mind you, when solving questions as regards to Lusac's law of combining volume, both temperature and pressure are kept constant, so we don't need them, right? So the volume of the residue gas is, that's what they're asking, what becomes the volume of the residue gas. So in balancing this up, we're going to have N2O, right? But then you see that we're having 2 oxygen here, we're having just 1 here for the product side, and then we're having 2 nitrogen. Remember, this side is the reactant, right? All of what we have here is the reactant, right? All of these are reactant, while what we have here is the product. Right, so we have 2 oxygen here, we have 1 here, we have 2 nitrogen here, we have 2 nitrogen here. So what do we need to do to balance up the equation? So if I put 2 here, 2 nitrogen, I have 4 here. If I put 2 here, I have 2 times 2 giving me 4 nitrogen, but then I have 2 oxygen, right? So it means I have 2 nitrogen, 4 nitrogen, sorry, 2 oxygen, 4 nitrogen, 2 oxygen, right? If you can balance chemical reactions, it's very easy for us to understand. So the volume, we are balancing their mole with their volume. We have 2 mole here, that's 2 volume here. Here we have just 1 volume here, right? They do so in simple ratio. Here we also have 2 volume in moles, right? But this is just the first part of it. We are looking at the volume before spark. Let's look at the volume before spark. It said 100 cm cube of nitrogen. So before the spark, we had 100 cm cube of nitrogen here, right? Before spark, that's BS, right? Before spark, we had 100 cm cube of nitrogen. It sparked with 30 cm cube of oxygen. Here we have 30 cm cube of oxygen, right? We're looking for the volume of the residue gas. It's very simple. The residue gas means the remaining gas. So I'm going to be showing you my hack on how to solve problems like this as regards to Dalton's law of partial pressure. What we need to do, first of all, let's look at 2 cases. Let's bring all the equations we have here and take them in cases. For case 1, let me make this guy the subject of formula and then find the volume during spark here. What I mean is for 2N2 plus O2 here, remember we have 2 volume here, right, the mole, and here we have 1 mole here, right? Let's make this guy subject of formula. Let's isolate this guy. Let's assume we have X here, and then here let's leave the 30 here. Let's assume we have the 30 here. By cross multiplying, if after cross multiplying the volume we get here is less than this, that's what we are going to use to subtract, right? What I mean is, if after we cross multiply, I have X times 1 here giving me X is equal to 2 times 30, 2 times 30, which gives me 60 cm cube. And if you check, the value for X here is 60 after cross multiplying. It therefore means that 100 is higher than 60. Look at now, we have 100 cm cube is greater than 60 cm cube here. It means we are going to use it, because before it sparked, they give us a volume. During the spark, the original meaning is that the volume is going to decrease per time, right? So at this point, by making here subject of formula, we got 60. Now let's make this part subject of formula. Let's see if we make here subject of formula, what we are going to get. If the volume here is less than 30, we'll still apply it. But if it is higher than 30, it means we are going to leave this 30 at the same place where it is. So for case 2, let's assume we have the same thing, 2 nitrogen plus oxygen, right? Remember their moles, we have 2 here and we have 1 here, right? And then here was 100, right? Making here 100 and isolating here, making here subject of formula. Here we put our 100 cm cube. Let's make here X. And let's cross multiply. If after we cross multiply, X times 2 gives us 2X is equal to 100 times 1 gives us 100. If we divide both sides by 2, 2 takes off 2, S become 100 divided by 2, 50 cm cube. You see that when we calculate this 50 cm cube is higher than the 30, which is not supposed to be. If you watch, you see that 30 cm cube is less than the result, the one we just got, 50 cm cube. That means we can't use this, rather we will use this. What does that really mean? It means we are going to use the 60 we got here, putting 60 cm cube. Since we cannot use the 50 cm cube, we remain the 30 cm cube here. And in their mole ratio, if we have 2 here and 2 here, it means that during the spark, 60 here will be 60 here, right? So let's put 60 cm cube here. So this is before the spark, this is during the spark, ds. Let's look at volume after the spark. If we subtract 100 minus 60 gives me what? 40 cm cube, right? This is the one that was remaining. 30 minus 30 here is 0. And from the product side, if you watch, there's nothing here, so it's just 60 cm cube. Are we making sense now? So the volume of nitrogen remaining after the spark, let's call it after spark AS, right? The volume of nitrogen remaining after spark is 40, and the volume of the product is what? 60. Therefore, the residue will be what? The one remaining, that's 40 cm cube plus the one of the product, which is what? 60 cm cube. Together we have 100 cm cube. That's how to find the residue gas. First of all, you form their equations. Next, you put them in their volume ratio, and then you bring whatever they give to you, the volume that was given to you, 100 cm cube of nitrogen and then 30 cm cube of what? Of oxygen. Then you apply my hack, my trick, right? Bring these two of them, and then put one here, isolate one, let here be X, let here be 30, right? We are doing this to find which one reduces after or during the spark, right? By doing that, you see that this one reduced during the spark, this one increased during the spark, so we don't need it. This is wrong, it's a wrong value. So by doing that, we subtract. 100 minus 60 gave me 40, 30 minus 30, we'll just leave the 30 there since we cannot get the actual value for this. We got 0, and since we have 2 more here and 2 more here, the chances that what we got here will be equal to what we got here. Are we making sense? So if it's 60 cm cube, here also is 60 cm cube. By subtracting, we got 40 and we got the 60 here, and then what happens? The residue becomes the remaining. If you do that, this is the remaining we have. So 40 plus 60 give us 100 cm cube. Let's look at 3 other questions as regards to Lussac's law of combining volume. See you in the next video. Alright guys, let's look at question 2 as regards to Lussac's law of combining volume. Right, the question says 30 cm cube of hydrogen. Now, before that, let's look at the mole, right? The volume. Since we have 2 mole here, so it is 2 volume here, right? In ratio, there's nothing here, so we're assuming it to be 1, right? So we have 1 volume here. Also here, we have 2 here, so we're assuming it to be what? 2 volume here. We're looking at their mole, right? They're forming a ratio. So it's a 30 cm cube of hydrogen as STP, so standard temperature and pressure. I told you we don't need them, they are constant, right? Alright, so 30 cm cube of hydrogen. So here we have 30 cm cube of the hydrogen, and this one is our volume before spark, right? Volume before spark, SPARK. Alright, so 30 cm cube of hydrogen at STP combined with 20 cm cube of oxygen. So here we have 20 cm cube of oxygen before the spark. This is what we have when they combine to form steam. According to the equation, this is the equation. We're calculating the volume of the remaining gas, that's the residue gas, right? So I said for this, we draw a line. Bear with me, a line might not be that straight. Yeah, but it works, right? Yeah. So in doing this, let's look at the volume during spark here. What do we have here and what do we have here? Mind you, what we're supposed to have here and here must be less than any of this. If the volume we're going to have is higher than this, it means we can't use it, right? So I give you my hack, right? So for case 1, we have 2H2 plus what? O2, right? We're using for the reactant alone. And here we have 2 mole Here we have 1 mole, right? Let's make here x, right? The one we have, let's make here x and let's put 20 here. Here is x and here is 20, right? If we cross multiply, we discover that x times 1 gives me x equal to 2 times 20 gives me what? That's 2 times 20 gives me 40 cm cube. You'll see that we can't use it. So what we have here, which is here, we're having 40. Are you getting? So this our 30 is less. 30 for this is less than what we are getting here, which is 40 that was given here. It's less than 40. We can't use it. Right? It can't work. Alright, so let's repeat the equation and make here the subject of formula to see if it will reduce. So we have again case 2, 2H2 plus O2, right? For this, we know we have 2 mole. This is our 1 mole. And this place here we have 30. Let's call here X. That will make any sense? So in doing that, we cross multiply. Right? So X times 2 gives us 2X equal to 30 times 1 gives us 30. So we divide both sides by 2. This cancels this 2 here, 1. 2 into 30 should be 15. So our X is equal to 15 cm cube. That is what we are getting here. For here is 15. It's less. That means we're using 15 actually. We can't use this one. We can't put 40 here. Rather, we'll repeat the 30 we have here. 30 cm cube. But here we're going to use the one less, which is what? 15 cm cube. Now, because we are having 2 moles and 2 moles here, the likelihood that what we're going to have is 30. Not making sense because there are 2 mole. 2 mole produces 30, 1 mole produces 20. The 2 mole here, the moles we are having, likelihood here is going to be what? 30 cm cube. Let's subtract, right? This is the volume during spark, right? Volume VDS, volume during spark. Let's use a smaller word for this so you get it. This guy is the volume before spark, volume during spark. What about the volume after spark? Let's see the line. Right, to get the volume after spark, we'll subtract, right? 30 minus 30 we got 0. So this is our volume after spark, VAS, volume after spark. 20 minus 15 we got 5 cm cube. And since there's nothing here, it remains 30 cm cube, right? So the volume of hydrogen remaining was 0, right? Everything was used up for hydrogen, right? So we can say volume of hydrogen is equal to 0 cm cube. Nothing was remaining. And then the volume of what? Of oxygen remaining is equal to what? 5 cm cube, right? And then volume of the product, after spark is what? Still 30 cm cube. So what becomes the residue? The remaining, the sum of what we have here, sum of all 3 of them, right? You can say therefore our residue gas stroke remaining gas is equal to what? 0 plus 5 plus 30. 0 plus 5 plus 30 all in cm cube. That gave us what? 35 cm cube. That's our answer. See how easy it is now. So if you go through the video, you see how easy I did it. Very, very simple, simplified approach for you to work with. Let's take yet again another question as regard to the Lussac's law of combining volume. Please make sure you like, you share the video, and you subscribe to the channel. That will help us grow a wider audience. I'll see you in the next video, guys. Thank you.